two hosts with a ho 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 Christmas special. We have been musicians for a very long time, and recently we discovered that there is math or trigonometry in music. We all know that there are sound waves when you create music. Well, that sound wave resembles a sine wave. And we can manipulate the equation of that sine wave to make the chord or note softer or louder by increasing the amount of times it oscillates per second. But for us to actually make a note, the sine wave needs to oscillate 440 times per second. Changing the amplitude of the sine wave, that is how high and how low the graph goes, changes the volume of the sound. And if you correctly manipulate the formula, sine 440 times 2 pi t, you can produce different sounds. An example is sine 440 times 2 pi t, which is A, sine 440 times 2 raised to 4 over 12 times 2 pi t, which is C sharp, and sine 440 times 2 raised to 7 over 12 times 2 pi t, which is E. And another example is the A major scale, which starts at 440 Hz, then increases over 8 steps to A2. Along the notes A, B, C sharp, D, E, F sharp, G sharp, and A. Well, that's not the only thing math can do. We already know that sound waves in music can also be represented by sine waves. But we can manipulate it even further by incorporating cosine waves too. Imagine a point moving counterclockwise on the unit circle at a constant speed. That's what a solenoid looks like. From there, we can represent the x-coordinate of the position at any future time at the formula cosine 2 pi times frequency times pi. On the other hand, the formula sine 2 pi times frequency times time is the y-coordinate of the position at a future time, which is the x-coordinate, phase shifted by a quarter of a cycle. And that's how we manipulate a solenoid. So a different note can sound different played on different instruments because an overtone is a tone having a higher frequency than the note being played. An instrument in general can play different number of overtones, and these overtones may vary between different instruments. The reason why different instruments have different notes because they don't play a single sine wave. So let's consider the string of a ukulele, then the length of the string. This decides what frequencies you hear since the string is attached at both ends. Mathematically, this corresponds to dividing a period by an integer, which means multiplying an angular frequency by an integer. So we play the C chord, the G chord, the A chord, Lastly, did you know that mathematics is involved in making music sound good? This is how one of my favorite musicians, Beethoven, who was deaf,
made such amazing music. For example, in his famous composition, Moonlight Sonata, the graph above shows the notes used and the waves it represents. You see that they intersect at some points, and that's the reason why it sounds amazing. This pattern is called consonance.
Consonant musical sounds are often described with words like pleasant, agreeable, soothing, and melodious. In other words, notes that sound comfortable when played together are considered consonant. The commonly used perfect intervals in major and minor thirds are all consonant, and the vast majority of people would agree that this sound is generally satisfying and enjoyable to hear.
While some parts in his composition shows dissonance. Dissonance is where the waves are out of sync, which is a bit off when you listen to it. Like this.
Conversely, dissonant musical sounds can be described as sharp, jarring, unnerving, or unsettling. This is because dissonant sounds create tension that the listener naturally wants to hear released. Intervals such as seconds, sevenths, and the tritone have a dissonant sound, as do the chords which feature them. Dissonance isn't just a term to describe music that doesn't sound good. Far from it, in fact. Classical musicians and jazz musicians are known for strategically using dissonance in their music to create rich, emotional, and moving pieces.
This just proves that mathematics is very important to us and is used in our daily lives. So that's for today, ladies and gentlemen. Stay tuned for the next episode of Two Hoes.
And that's it. Thank you for watching a Ho 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 Christmas special. Have a happy holiday!